So moment of inertia tutorial questions number 2. Things to bear in mind in this one, in addition to what we've been talking about already, are that we have in this particular question, the flywheel has a moment of inertia, and we can calculate that because we know its mass and the radius of gyration, k. So actually, Alan, in this particular case, we don't need to take into account is it solid flywheel or is it a rimmed flywheel, because it's giving us k directly. The radius of gyration is 220, so that's giving us k. And we have to add to the moment of inertia of the engine the moment of inertia of the engine parts, the rotating engine parts. So the total moment of inertia is the moment of inertia of the engine parts, which is 4.2, plus the calculated value for the moment of inertia of the flywheel. And then, to get the total torque, you need to take into account that there's also friction involved. Well, what torque is required to overcome friction? 6 Newton meters. So to get the total torque, we need to find the torque necessary to accelerate the engine, this bit. So that's what you calculate using the formula torque equals I alpha. And then once you've got that, you add this extra friction torque of 6 newtons to get the total torque at the end. Okay, so now have a go, write down what you know and put the values in and calculate it. So we know the mass, we know the radius of gyration, we know the inertia of the engine. It starts at rest, so we know that omega 1 is 0. Omega 2 equals 2 pi times the frequency, which is 1500 over 60, which turns out to be 50 pi radians per second. And we know the time is 20 seconds. So now we're after the total torque. So we're after the engine torque first of all. So the engine torque is I alpha, where I is the total moment of inertia. We can find alpha because we know omega 1, omega 2 and t. So alpha equals omega 2 minus omega 1 over t. I we can calculate because I equals mk squared plus the moment of inertia for the engine. So that's the flywheel. And so then we can do the question. Okay, so putting in the values, the moment of inertia for the flywheel is mk squared, so that's 80 times 0.22 squared, which is 3.87. We now add that to the moment of inertia for the engine, so we add 4.2 to get 8.07. Alpha, it turns out to be 50 pi over 20, which is 5 pi over 2. So therefore the engine torque turns out to be 8.07 times 5 pi over 2, which is that. Add the friction and you get 69.4. Okay?